Hi, my name is Jennifer Blaize, and today I'll be showing you an example of how to solve a system of linear inequalities. For this example, the student should already know how to graph linear equations, how to graph linear inequalities, and how to solve systems of linear equations. If you recall how to graph a linear inequality, you would isolate your y variable, graph the line using y-intercept and slope, and then shade to show your solution set. So we're going to apply these same steps to our system of linear inequalities. So here we want to solve for 2x minus y is greater than negative 3 and 4x plus y is greater than or equal to 5. So our goal is to find all of the ordered pairs that are going to satisfy both of these inequalities at the same time. In other words, if I were to plug in x and y for both, I would get true statements for both of these inequalities. Okay, so we're going to go ahead and begin with our first one. We have 2x minus y is greater than negative 3. So I want to isolate y. So I'll go ahead and subtract 2x on both sides, and that gives me negative y is greater than negative 2x minus 3. And then I want to divide both sides by negative 1. So I get y is less than, don't forget to switch your sign, 2x plus 3. Then I want to go ahead and graph this line using my y-intercept and slope. So I'm going to come over here to my graph. My y-intercept is at 0, 3. And my slope is 2. So up to right 1, up to right 1, and then I'm going to go down to left 1. Okay, so to connect these dots, I want to go ahead and leave this line open or dashed, if you will, because my symbol for this inequality is less than, not less than or equal to. So that means that the points on this line are not actually part of the solution, only the points that are less than this line. So then we want to go ahead and shade. So we're going to shade below the line. And hopefully the direction that you're supposed to shade is intuitive to you. But if it's not, you can always choose a test point in your shaded region to make sure that you've shaded on the right side. So here I'm going to choose the test point 0, 0. So I'm going to test 0, 0. So I plug in 0 for y and 0 for x. And when I simplify, of course, I get 0 is less than 3. That is a true statement, so I know I have shaded in the correct region. All right, then I'm going to move to the other inequality, my second inequality, 4x plus y is greater than or equal to 5. All right, so again, isolate y, graph, shade. So I'm going to subtract 4x from both sides, and here I have y is greater than or equal to negative 4x plus 5. So I have my y-intercept at 0, 5, and my slope is negative 4. So 1, 2, 3, 4, right 1, and then 1, 2, 3, 4. Okay. For this line, I'm going to go ahead and make it solid because my symbol is greater than or equal to, meaning the points on this line are part of my solution. And so for my shading, I want to shade greater than my line above my line. So that's going to be this direction. And again, if you're unsure about where to shade, you can pick a test point from your shaded region. So let's say we might choose the point 0, 8 to test. So I'm going to let x be 0 and let y be 8. So I get 8 is greater than or equal to negative 4 times 0 plus 5. So of course that's 8 is greater than or equal to 5. Again, that's a true statement, so I know that I have shaded in the correct region. Okay, so you notice that I did this in two different colors, right? The green shading represents the green inequality, and the red shading represents the red inequality. And I did this on purpose because when you come over here and look at your graph, it's pretty easy to see where the green and the red colors overlap. And where this overlapping happens, all of the ordered pairs in this overlapping are part of your solution set. So you could choose, so what that means is you could choose any ordered pair from your solution set, any x and y, plug them in here, and you would get a true statement for both of these. So that is my example of solving systems of linear inequalities. Thank you.